Welcome to the TechEd session. My name is Pavel Fraenkl and I'm SAP Finance Consultant at Center of Excellence of the Carrier Company based in Prague, Czech Republic, Europe. I'm also acting as a lead for automation and RPA activities for our SAP implementations in EMEA region. Today, we learn about how Carrier leverages RPA. Here with me today is Mathias.
Thank you, Pavel, and hello also from my side. My name is Mathias and I'm part of the SAP S/4HANA product management team in a customer-facing role called the frontrunner team. We help customers to explore and adopt innovations. And as I, together with my colleagues from SAP Consulting, did help Carrier with their first steps in RPA and S/4HANA, I will later dive a bit into the technology topics. Before that, back to Pavel for the introduction.
Thank you, Mathias, for the introduction. Now let me go through the agenda of this session. I will briefly introduce the project where we had the opportunity to leverage the Intelligent RPA. We will have a look at the short demo at the system. Then my colleague Mathias, who participated on the bot solution implementation, will explain the technical details of the bot design. And at the end, I will briefly speak about the future of RPA in our company. Let me say a few words about our company. Founded by the inventor of modern air conditioning, Willis Carrier, Carrier is a world leader in high technology heating and air conditioning solutions. It is an international company based in the US, producing refrigeration and HVAC devices and delivering turnkey projects and maintenance services. Its gross sales in the 2019 were reaching 18.6 billion USD. Carrier was part of the UTC group until the split in April of this year, when it was also introduced to the New York Stock Exchange, where its stocks are performing very well. The biggest customers of its segment, Carrier Commercial Refrigeration in Europe, are leading retail food store chains like Lidl or Rewe. And among its cooling installation projects, we can mention, among others, Sixtine Chapel in Rome, Italy, Singapore Expo, the Asia's biggest expo hall, Residence and Gardens of George Washington in Mount Vernon, Virginia, USA, and the Great Library of Alexandria in Egypt. So let me say a few words about our project where we leverage the RPA. It was the S/4HANA Cloud implementation in Norway. The go-live was during the Corona crisis, so we were working remotely, and our delivery partner for the project was SAP. During the implementation, we came across the obstacle. We did not have the API available for specified tedious activity in the sales area, and the bot solution enabled us to quickly implement the replacement solution for this problem. Let's have a look into the opportunity we identified together with the business, the automation challenge. We have identified basically two opportunities where we can leverage the RPA. The first one is update the sales order when we need to populate each and every item of the sales order by the WBS element. The sales order can contain many, up to hundreds of the items. So this is very tedious work to go and have several clicks in each item of the sales order. Other opportunity we saw is the Create EPPM, or so-called enterprise project, where we have not implemented yet this functionality, and we will work on this in the future. So now let me talk about what is the robot actually doing in the system. So first, he's opening the sales order, which we can see on the top left corner, and entering the number of the sales order. Next, he's going item by item. We can see on the left down corner. In the item, he clicked on the account assignment tab, and within this tab, he's clicking on the profitability segment, which we can see on the right screen. Here there is a field WBS element, which is going to be populated by the bot. We will see that later in the demo acting of the bot on the live system. Okay, now about the demo. It is consisting of 4 parts actually. First, we will have a look at Design Studio, where the bot was designed and where the screens were captured, and we will see the bot workflow. Then we will see bot in action. After that, we get to know the RPA factory, which is a monitoring and orchestration tool for bots. And we will have a little bonus surprise video at the end. So now we will have a look behind the scenes and watch the short demo. Here we are at the Desktop Studio, a design tool for the robot. Here we can see the workflow of the robot and the captured screens. Firstly, it is logging into the SAP system, opening the sales order, and for each line item, it is filling our corresponding field. As you can see, there is quite some conditions that it takes into the account. Let's jump into one of the screens. Here you can see the pop-up of the profitability segment and that the bot is entering the project number accordingly. After it's done, it's saving the sales order. Now let's have a look on bot execution. So we are starting the bot manually from the RPA factory. Let's switch to the virtual machine and we can see bot start acting by starting the browser. And now I'm not moving my mouse, the robot is acting, going to the individual items of sales order and filling the values. After a while, bot is finishing and saving the sales order. Then he logs out and closes the connection. We can go back to the factory and let's check the job we just finished. And we will see the log with the 9 updated line items. So now have a look on the RPA factory, which is a monitoring and orchestration tool for the robot run. Here we are at the landing page where we can see the dashboard. And moving to the packages, we can see we have a released project, Turnkey RPA, in the version 3.1.2. Also, we can see some additional projects we get from the store. There are many RPA bots out of the box, which can be just downloaded here. So let's have a look on the Agents tab. We can here see the available agents and their statuses. We have 2 active agents which are now in the ready and idle status waiting for the job assignment. Let's have a look on environments. We have 2 environments which are connected to the Q and to the P system. Let's check the quality environment first. So here we can see the version we have deployed on this environment, the triggers. We need to migrate to the new version here. And here we can see the manual trigger from where we can manually run the bot execution. To be able to do, we can edit the parameters like a scheduled run when we want to trigger, and the input parameter. In the input parameter, we can enter manually the sales order number. This trigger is automatic and is run when the user hits the save button on the sales order. So let's have a look on the agents. Here we can see the assignment of the machines which are assigned to this environment. Also, we have here the variables which are defined for this environment. For example, we have the delay before the bot triggers, and we can see it is 5000 milliseconds, making it 5 seconds before the bot runs. Here we have also defined the different technical uses of the bot. This is for the API, and this is for the UI. Let's go back and have a look on the productive environment, where we have the same package deployed, and we have basically the same triggers. We also have the same variables, and we can define the different values, like, for example, the user in the productive system. Let's go to the monitoring tab. Here we have the dashboard overview, when we can see the most important characteristics. We can see today we have the 17 executed jobs so far. So let's have a look on the jobs executed. Here we define the time range. We can filter by various criteria like environment or machine or the manual trigger or the automatic trigger. Let's have a look for 2 days beginning yesterday, and we can see we have all successful jobs here. We can dive into the job to see the output log, and here we can see the sales order number which was processed, and scrolling down we can see the message, and we can see the individual items which the bot was updating, and we can see the final messages of the bot. Here we can see he updated the 3 items. Let's move to the configuration tab. Here we can configure the mail communication and the mail server. It is used to get the alerts, for example, when the agent is down. It can trigger automatic email to inform you about this situation. Okay, let's move to the store, which is the last tab. Here we can see the offer of the ready bots out of the box. We can filter through the, for example, line of business. So for example, let's say we are looking for the finance implementations. And we have here many bots for the clearing, for the posting of the items. Let's say we are looking for the bot for posting of manual entries. And we can see we have different bots for posting, feeding different transactions, for example, FB01 or F02. Here's the description of the bot. Also, it comes with the Excel templates, which can be filled and fed to the bot. Here with this button, when we get the bot from the store, it will be updated in our packages and projects. Okay, this concludes the demo for the IRPA factory. And let's move to another example where we can see multiple bots performing. Now we can see 10 different screens and starting multiple jobs at the same time at the peak when we are seeing 10 bots acting at the same time, processing different sales orders. Okay, so thank you for watching the demo. Now we are going back to the project milestones of the Norway project. So we can see the kickoff was in the late January and we have go live in the May. So regarding the bot implementation, it took us about 4 months to implement fully. SAP helped us with the design of the bot, where there have been several updates during the solution. It has always been tested in the queue system first, together with the business users. This showed some behavior of users which was not primarily expected, so we had to adjust the bot. Mathias will later mention the example. We improved and tested the bot in iterations. After a short period, we went live in the productive system. Afterwards, we have been monitoring the bot run and analyzed whenever the bot did fail. We had another 2 improvement cycles fixing special cases after go live. Meanwhile, now the bot is running well and nowadays requires minimal monitoring. So let me talk about the advantages the bot brings to us. It saves 30 minutes an average of manual work each day. And we need to imagine that we are in Norway, which is a very labor expensive country. We have a big advantage to avoid the human errors. I mean, sometimes there are 2 types of the errors. We can have the item left out and not populate the value, so it leads to the empty field in some of the items of sales order. Also, we can hit some error during the filling of the value of the field, like a typo, which means to misinterpretation later in the financial documents. So now we will have a look about the average month and how the bot performs. On the screen, we can see the sales orders processed by day. Approximately, we have 30 to 40 orders daily reprocessed by the bot, making it below 1,000 bot transactions each month. So now let me hand over to Mathias, who will explain the architecture and how they implemented the bot.
Thank you, Pavel. So as Carrier in the beginning did not have experience with robotic process automation, we brought in SAP DBS, so our consulting team, to help with the very first version of the bot. With that said, in the next minutes, I will provide you some insights into the underlying architecture and technology. I will show how the colleagues did connect the robot to the SAP S/4HANA cloud system and cover a couple of challenges we run into. So the following picture outlines the process as well as the high-level architecture. On the right hand, we see a typical SAP S/4HANA cloud system with its web-based front-end and ABAP backend. As you might know, S/4HANA Cloud is our software as a service version of S4, running completely in the public cloud. So compared to on-premises ERP systems, this is a pure web-based user interface, and also options for customization or modifications are of course limited. So here an RPA approach comes in handy as it simply runs side by side to S4, keeping the core clean. Besides the user interface, S/4HANA, of course, still has a backend running an ABAP application server and the HANA database. Access to that layer is directly possible via REST APIs, and I come to that also later in more detail. On the left, we see the human business user on the bottom, as well as the robot top left. Let us go through the process step by step. So we start with the business user who is accessing the cloud ERP system with a web browser of choice. The user starts to create a sales order. He confirms by clicking the save button. And with this action, the robot is started in background by the S/4HANA system. So the business user does not interact or see the robot, and he can proceed with his tasks. So he's not interrupted in his typical workflow. The robot itself is running on a server machine hosted in the cloud in Carrier's case. So as a first step, the robot uses an REST API call to retrieve further details about the sales order, here in the picture number 3. So this call is simply made to check if there is relevant changes in the sales order, which would require the robot to process. If there is no such changes, the robot can immediately stop. But if there was relevant changes, the robot starts acting. This helps basically to avoid unnecessary actions by the robot, and it is reducing the runtimes in the end. So the bot then opens the SAP S/4HANA user interface, logs into the system as a technical robot user, and starts to post-process the sales order, as you have seen in Pavel's demo before. After the robot saves the sales order, he leaves the system again and waits for the next wake-up call. As everything runs within the cloud, no cloud connector or VPN is required. All communication uses the standard HTTP protocols. Let us have a closer look at the actual trigger of the robot here in number 2. So there's various options typically that how a robot could be started. And as RPA is using a consumption-based pricing, the number of robot starts is indeed a relevant metric. So we discussed in the beginning a nightly batch run, but quickly also came to the conclusion that post-processing should run immediately to also not interfere with subsequent process steps. Second, the teams then consider to simply react on events happening in S/4HANA. So S/4HANA comes with so-called business events. For example, when a sales order is changed, an event would fire. But in case you don't know events, you can also look them up in the API Business Hub. I have a link later on the slides. But in Carrier's specific case, the project team, however, decided to also only start the robot in very specific cases, in very specific conditions, and to use a small logic within S4 to only start the bot when needed. So here we see that actual implementation of the so-called cloud BAdl, short for Cloud Business Add-in. What is a business add-in? Basically a user exit written in ABAP language, which is fired within a specific step of a process. In our case, whenever a sales order is saved, this BAdl runs. As you can see in the first lines, the logic is checking a couple of preconditions, like if the corresponding project exists, if a specific distribution channel was set, and a specific type of sales order was selected. And only then the bot is actually started. Also, the very first line, for example, avoids that the robot would start itself after saving the sales order. If all conditions are met, the robot is then started via a simple HTTP request here on the bottom. So this is happening also in an asynchronous manner so that the user is not interrupted. So what happens in background is that the job is queued in the SAP Intelligent RPA factory, which is the orchestration component of RPA. The bot agent, so the actual runtime of the bot, is then retrieving that job out of the factory's queue and starts to act. As you can also see in the call, the number of the sales order is handed over so that the robot knows which order to process, which also comes in handy when monitoring bots, as it allows to easily find jobs according to a specific sales order. The security tokens that are required to start the bot are stored in a central configuration table, separated from the code. RPA typically uses UI-based automation, which on the one hand makes it easy for non-developers to quickly create automations. You simply tell the bot where to click when. However, has of course also the downside that changes to the user interface might disturb your robot. And as S/4HANA Cloud is automatically updated 4 times a year, when automating on user interface level, this of course needs also to be considered. Fortunately, S/4HANA Cloud comes with a set of APIs, and also here the link to the API hub on the right-hand side, so that typically no user interface-based automation is necessary. Unfortunately, as Pavel already mentioned, in that specific case, the underlying business process required to enter data in a very specific field, not covered by any API as of today. And also the processing of sales orders typically requires numerous validations that need to be taken into consideration. So also that an API call would not be as easy probably. So the consultants chose to simply automate via remote controlling the user interface in that case. To still reduce the UI automation part to a minimum. However, the bot in the beginning, before it even starts to act, is using an API to already retrieve some information and minimize that time. As mentioned, as sales order processing is probably one of the most complex user interfaces in S/4HANA or in the ERP world. This also required the bot to deal with a set of special cases. Here on that slide, a brief sneak peek into some of the conditions the bot had to take care. And the picture might actually look simple if you really know sales order processing. However, of course, the robot only covers a very specific type of sales order and works well within its boundary conditions of carrier scenario. As Pavel mentioned, also some of the special cases showed up only after productive use. On the positive side, the specialization of the bot to carrier scenario allowed to implement it in a very short time frame. However, as soon as the business users might adopt further features within the sales order process, it might, of course, also then require further tweaks to the bot in future. One other challenge carriers end users had concerns with in the very beginning was the overall performance of the bot. So in general, when working with user interface bots, they also behave like an end user sitting in front of his PC. A fast end user, however, still limited to the speed of the user interface. In carrier's case, the robot had to deal with hundreds of line items to be updated, running through each line item, opening the pop-up, entering the number, closing the pop-up, and so on and so on, as you have seen in Pavel's demo. So we decided to early on start with measuring runtimes and doing performance tests and also optimizations of the robot. Here in the chart, you see a typical day of a robot process that was recorded during one of the early end user tests and shows typical runtime. So on the x-axis, you have the single runs, and on the y-axis, the runtimes in seconds. And so, for example, also you can see 2 spikes that show up here on the left and right. And interestingly, those have not been caused by bad performance of the bot, but simply because end users used to click the save button in between a session without closing the sales order. This started the robot, but the robot was not able to access the sales order and had to wait until the user would close the sales order. And of course, in retrospect, a quite obvious behavior, right? No one trusts computers. people simply save intermediate stages. The robot, however, was simply locked out of the sales order during that time. So also here we slightly fine-tuned the bot behavior to accommodate. Another aspect is that a single robot can only work on a single sales order at a time. So during peak times, we had 10 or more business users processing, saving sales orders at the same time. So a single robot would then just sequentially work through the job queue. Nothing too bad. However, Carrier also wanted to have timely processing of jobs. So we simply added further robot agents to process jobs in parallel. And that's what you have seen in Pavel's demo in the end, where the 10 screens were just running in parallel. To conclude, especially when doing UI-based automations, we can stress the fact that ERP processes are versatile and complex. So it's essential to work with the business expert to build up a comprehensive set of test cases. This also allows us to quickly and on a regular basis run these tests when there is release updates or other changes in the system. But that considered, SAP Intelligent RPA allowed us to quickly automate this manual and tedious process that for sure no end user wants to do manually. With that, back to Pavel for a summary and outlook.
Thank you, Mathias, indeed for the valuable insights. So now let's sum it up and have a look at the outlook of the bots in our company. So as I commented, we have one country live in S/4HANA Cloud, and this year we are kicking off another project in another country, and for next year we have 3 more countries in scope to implement S/4HANA Cloud, which gives in another scale for the usage of the bot. So the advantages of the bot implementation, it's really short lead time. Also, the bot runs as unattended. It means it runs in the background and user does not see the bot acting. It runs automatically on the background, which is advantage. We are looking for other automation projects beside the SAP S/4HANA Cloud. We have on-premise installations where we can also leverage the bot. So as I've mentioned, we are growing in SAP S/4HANA Cloud, but nevertheless, the bot can be integrated in non-SAP systems. Of course, the biggest advantage is the integration to SAP, sub-user interface, and so on. But it can be leveraged for logging in another systems. It can trigger the emails. It is integrated with Outlook and Word, so it can copy-paste and do the tedious work. So it can be leveraged for many reasons and automation. It is very scalable. It means we run it on the virtual machine in Azure or Amazon Web Services, and we just need a single core machine with 1 or 2 GB RAM to run the bot, because he only starts the browser for this case. So for the future, we are building a team which will actively seek for opportunities to leverage the bot in our SAP systems and in our business processes. If you're seeking more information for this topic, you can reach out for another TechEd sessions, which are mentioned here. You can also leverage the public resources for the Intelligent RPA SAP technology in the website mentioned below. So we come to the end of this session. Thank you very much for your attention. If you want to reach out to us, here are our contacts. Thank you, Mathias, also.
Thank you for joining our session and wish you a good virtual TechEd.